My pleasure to introduce Ivan, longtime trooper, and one of his favorite topics, I'd say, real-life automation wins. I think the title speaks for itself. Stage is yours.
Thank you. So we'll skip this slide. We had the intro. I started talking about network automation a few years back, as many of you know, and you always get the skeptics. And as I was writing about what a large enterprise, and I have that enterprise as one of my last slides, was doing in their deployments, someone wrote this comment. Well, would you mind elaborating on? Anytime I see a comment starting with this, it's like bullshit. And then he goes like, I have 7 vendors, I have 20 platforms, I have 3,000 devices, how can I automate all that? And luckily, I didn't know whether this was a troll or whether this was, an honest comment, like I'm totally lost. My first reaction is always, this is a troll, and then I calm down, and then I say, well, maybe he meant it. And someone replied, well, how do you eat an elephant? You eat it one bite at a time. But obviously, this guy didn't see the path. So I said, well, let's make it my mission to create the path for the networking engineers to eat the elephant. Because honestly, programming and system development and systems architectures and data structures are not our main focus in life. And now we are expected to know that. So this is the slide that I probably showed last year and the year before that and the year before that. Start with read-only access, do some simple stuff, and then start doing device provisioning, because if you brick a new device, who cares? If you brick a core router, everyone cares. And then start doing service provisioning, and don't mess up with real-time stuff until you really know what you're doing. Still doesn't help. People need a path. So even if I tell you, what you should be doing, it's like, nah. Next step, I created this online course. And I split it into 6 modules, starting with the big picture, and then the easy wins, the read-only stuff. And then we spend a lot of time on the data models and how you structure them and why they're important. And then they start developing configuration out of the data models and pushing that to the devices, and eventually move from device provisioning to service provisioning. And then I try to hammer into them that testing is good. Validation is a must. Unit tests are a good idea. I even had someone talking about CI/CD pipeline in networking, where he would spin up a virtual lab out of Cumulus VX boxes and download the configs on the boxes and verify that the BGP neighbors would come up in a simulated fabric environment. Totally automated in GitLab, because GitLab is the only CI environment that allows the runner to query the server. He was running behind NAT. Okay, anyway, and then the big picture, putting it all together. And the idea of this thingy is create something that you will deploy in your production system. And I was totally amazed that a lot of people did. And this presentation is their story. It's about what other people out there did, and I only included the ones that really surprised me. So the sample size, around 300 people. They're all building stuff, and you might ask yourself, why are they all building stuff? Isn't there enough stuff out there? I mean, look at the vendor PowerPoints. They do everything, right? Everything works so great in those demos. These people disagreed. There's a bit of a selection bias, because they wouldn't be in the course if they wouldn't want to build stuff. And building is fun and sexy. There are also other things. There are tools that do what these people did, but they didn't have the tools. Or the tools would be too expensive, or they didn't have the time to install the tool. Or I don't want to install this humongous tool to solve this little problem. Like, you're buying the Lego Death Star at 500 euro just because you need this one figurine. Doesn't make sense. So there are all sorts of reasons why these people decided that it's time to build stuff. And let's see what they built. The Easy Wins module starts with grab something from the boxes, do something useful with what you grab from the boxes. And I was totally surprised at one of the first things that came in. A system integrator helping a large customer, and the customer had a power outage on a campus network. hundreds of devices, all on UPS. Another question was, did all the UPSs survive this long power outage? So how do you know that? You log onto all those devices, you look at the uptime, right? If the uptime is longer than when the power outage happened, we're good. Otherwise, we need to check. How many of you had to log into hundreds of devices to check uptime?
At all or manually? At all or manually?
Manually. It turned out that this guy had 0 tools in place that could answer this question. I don't know whether the customer didn't have network management, or whether network management didn't have the capability to export data, or they didn't monitor the uptime, or whatever. There was no tool. An Ansible playbook later, he had his report. By the way, at the bottom of the slides, there are usually URLs. It's either to my blog post about these guys, and in the blog post, there is usually, if they provide it, a link to their GitHub repo. Sometimes I have directly links to the GitHub repo, so most of this stuff is available online for you to use. Copy, reuse. That's the idea. You've heard that in the keynote. He had this other idea. Namely, they were running this construction project, and the subcontractor was installing switches and wiring switches, and this is taking a year. And he had to be the project manager on this, and he had to know how many switches were installed and whether they were wired correctly. Well, were they installed? It's easy. You ping them. If they respond, obviously, hopefully, they're there. Are they wired correctly? Well, that's a trickier part, but we have LLDP, so you could get LLDP neighbors. You can verify whether you see the right switch on the right port. Do you know what to expect? And that was the real problem in this case. He had to build a data model describing his target network. And then, with the data model in hand, he could log into all the reachable devices, do the show LLDP neighbors, compare the actual state to the target state, and report any discrepancies. I have someone else who is doing that in a data center environment to verify that their fabric is wired correctly. And I don't know whether this guy ever came to the optical transceiver powers, but I have another one who did exactly that. This guy wanted to monitor WAN latency. Yes, every router has some sort of IP SLA. Yes, every network management system has something where you could set those probes to monitor, and yet we're not doing it. So what he did was he wrote this very simple script that would take the list of all managed devices, create a half matrix, because you only need to do it halfway, of all the unique pairs, perform pings, reported latency, and highlighted any anomalies. Very simple, but pretty useful. Speaking of very simple and pretty useful, I had this great experience with a huge multinational company, and they showed me their IT monitoring center. It was like Houston, with the big screens and everything, and the red lights, and the whole crew working. And they went like, oh, they're using whatever vendor product, and we run a copy of SolarWinds, because that product couldn't give us WAN link utilization reports, which we need to justify link upgrades. So sometimes you just have to use a different tool. By the way, this is the other guy I was mentioning. On the Nexus switches, he is doing show interface transceiver details and parsing that with Python code and reporting all the ports where Nexus switch thinks that we have a transceiver fault. And he's doing that continuously in his data center environment and occasionally generating reports about which transceivers are about to fail, because the power levels are close to where they shouldn't be. So you can do proactive maintenance. How cool is that? How many network management systems can do this? Like none, because this is not in the MIB. These are one of those stupid things that you can only get with some arcane show printout that, by the way, changes with every software release, just for the fun of it. And changes with every single blade, because every blade has a different printout. All right. Another simple one. This guy tried to manage a Fortinet firewall. He said,
can we have the checkers picture there as well?
He said, it's impossible through the GUI or whatever to find what I need. And that's the problem with any GUI-based system. Why do you think this guy has his definitions in a text file and not in a GUI-based system? Because text files are versionable and searchable. And vendors don't get that, because they're selling to the guys who are impressed with the glitzy GUI, your managers. So what this guy did was he was downloading the information and putting it into a format that was searchable and usable. And as he wrote, sounds dumb, but never underestimate the power of brute force and text files. His next step, his goal is to write a system that will allow the sysadmins to ask for new rules through a web user interface, and then have the security team review those rules, you know, like this guy with his merge requests, and then deploy that automatically in production. And as he said, that will be a great day. He's not there yet. Another one came in literally 3 days ago. Anyone using Cisco ACI? No? Good, we don't have Cisco people in here. Cisco ACI has API. It has great GUI. I think you can now even get some text-based configuration out of it. The problem with that GUI is that the parameters that are relevant to you are spread over 6 different screens, as in any GUI-based product. Anyone running VMware? Have you ever tried to get any sense of what your virtual switch is doing? And in how many different places those parameters are? Same thing. It's not just Cisco ACI. It's every GUI-based thing. So what this guy did was they wrote an Ansible playbook, which is using Cisco-supplied ACI modules for Ansible, pulling down the information, collecting the information into the Excel spreadsheet. Because, as he said, everyone knows how to search in an Excel spreadsheet. And in the Excel spreadsheet, you have that top column where you can filter. So everyone knows how to do queries in an Excel spreadsheet, or pivot tables. So why not? The repository is here, so you can just go and look at his code. All right. These were the easy wins. Now for some fancier stuff. I created this as a proof of concept. I was like, OK, if I can grab LLDP data, how hard would it be to create a graph definition out of that? It turns out it's trivial, of course. And how hard would it be to use that data to create a real topology of the network? And it turns out that there's this open source package out there where the brute force power of text files, you pass the description of the graph as a text file to the tool, and lacking any better instructions, the tool creates your spaghetti for you. I would have to spend more time on describing exactly how I want my graph to look like. This is the default I got from my text file, but I spent like 10 minutes creating that text file. Other people took this idea and ran with it. And this is what one of them did. He is doing show blah, 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 whatever on his Cisco switches to get the information about a particular VLAN. So who is the root of the spanning tree? And on which ports do I have this VLAN in the trunk? And which are the access ports? And going down to the host level. Collecting this information, he creates that text file for that tool. And he creates the VLAN topology for this particular VLAN in his network. How many network management tools can do this? I don't hear any names. All right. How about this one? This guy did the same thing for IP multicast. So he uses some custom scripts. The problem with all this stuff is that you can't get the information out of the boxes in any sensible format. Well, you can if you bought from Juniper, or Arista, or Cumulus, but not if you bought from many other vendors. So assuming that you can't get the information out in any usable format like JSON or XML, you have to write your own parsers to screen scrape the data, collect it together, munge it into the format you need. Then you create that dot file, and then he creates the graph. And I love this quote. These guys are actually using this in production for troubleshooting IP multicast. Whenever they get a call saying it doesn't work, they run this script. The script takes a few minutes because it has to log into all the devices and do the show printouts and collect the data, creates this graph, and then they look at this. This is an actual graph from his network. Have you ever seen something like this from any network management tool? I haven't. There are so few people using multicast that no network management vendor ever spent any time on creating something that would be useful for troubleshooting multicast. And this guy just did it on his own. OK, moving forward, configuration consistency. This is like a major pain for everyone. How do I know that on all my routers I have the same syslog server configured? How do I know that on all my firewalls I have the same time zone configured?
Treat them like syringes.
You can't treat them like syringes because they come in these big boxes that have to be, racked and stacked.
Touch them.
Yes, you can hug them. Yes, I would love all the thingies that we use above layer 3 to be virtualized so that we can treat them like syringes. We're not there yet, and the vendors actually charge more for syringes than for the physical products. Let me not go there. Anyway, so the idea is always create some data model. From the data model, create some device configuration, push the device configuration to the device. This guy started playing with checkpoint firewalls. And what he does is he logs into the checkpoint firewalls and verifies that things like time zone and admin users are OK. Now, it's checkpoint. So there is no Ansible module for checkpoint. The only thing he could do was to use the raw commands, which were really SSH commands, straight into the device. Because that was the only thing that he could make work. Now, hooray for checkpoint, because they actually implemented SSH command mode. Many networking devices only implement SSH interactive mode, which means that you can't even execute a single command on the device through SSH. We are discovering them on a daily basis. There are some big name vendors. So, for example, on Cisco, Juniper, Arista, Cumulus, a checkpoint, you can do SSH user at host show version. On many boxes, this will just stop at the username prompt. It's amazing. Anyway, So he had to use the raw modules because Checkpoint didn't have anything for the release he is working on. Now, to be honest, Checkpoint did release some Ansible modules for release 80. This guy had an interestingly similar problem. He wanted to manage extreme switches and Fortinet firewalls and Cumulus switches in Linux servers. This one is easy because Cumulus switch is really just a Linux box. Anything works on a Linux server. What he wanted to do was NTPS, NMP, SSH, syslog, you know, the usual stuff. On extreme switches, he actually had to write an external Perl script that used the proprietary API of the extreme switches to push the data to the extreme switch. But he got it up and running, and now he has this Ansible playbook that manages, that ensures that all the devices in his network have these parameters consistently configured. Okay, moving forward to people who are doing slightly better and more interesting stuff. Ruben wanted to play around with these new things like Netcom and Yang data models and OpenConfig and IETF because, you know, after a decade, we got to a point where we are slowly getting the standardized MIBs for device configuration. Only they're called Yang data models. Anyway, what he figured out is that yes, I can do it. It actually works on iOS XE 16, but not before that. So you need really recent version of iOS XE code, and then it will work. He figured out that Ansible does support netconf, but only like halfway. He could configure the boxes, but he couldn't get the information from the boxes or get any operational data with Ansible. So everyone is looking at this like I don't care, this will never work approach. And he figured out that he could use the standard IETF-based data model to configure the interfaces and BGP neighbors, but not to configure BFD or route maps. He had to use Cisco's proprietary data model for this because there is no IETF data model, or because Cisco didn't implement the right IETF data model. Just so you know the state of the industry in multi-vendor device configuration. After a decade, it still sucks. Okay, someone else wanted to solve zero-touch provisioning. Now, we had zero-touch provisioning for decades. It was always based on this idea that the box would come up, it would query the DHCP server, the DHCP server would give the box an IP address and a pointer to a TFTP file. Did I say TFTP? It's still TFTP. Newer boxes can also take a URL in a slightly different DHCP option. And then the box would go there and download the config, and it would work. As it turns out, things are slightly more complex than that if you want to make it run in practice. So what this guy did was, he said, I want to implement zero-touch provisioning based on MAC addresses because they are printed on the switch. So someone would open a new box, take out the switch, write down the MAC address, put it into Excel spreadsheet because Excel. Don't get me started. Then when the DHCP assigns some random IP address to this one, he would scan the DHCP leases or the ARP table on the DHCP server to get the mapping between the MAC addresses and the random IP address. TFTP would already download minimal configuration to the switch. Then he had to log into the switch and do the magic command on Cisco iOS, crypto blah, 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 to generate the RSA key. That would enable SSH. You can't do that in the config because in the config, you know, crypto blah, 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 blah is not a configuration command. So you have to log into the box with Telnet to generate the SSH keys, and then you log out, and then you scan the box for the SSH key, because that SSH key is by definition random. And then you put the SSH key into the no-host file, And then the device is ready to be added to your Ansible inventory. And you can push the actual configuration to the device. This happens when a vendor solution grows organically over the last 40 years. In newer systems, things like RSA keys are generated automatically, and SSH is enabled automatically, so we don't have that problem anymore. This guy is one of my heroes. He is working for a telco, and they also build networks for the customers, so they have a staging lab. Someone would put all the equipment together, and then this equipment has to be properly configured. And this equipment being Cisco routers, the moment you turn on a Cisco router, it goes into setup mode. So what he did was he has the Ansible inventory describing what devices are in the lab, and he would connect to the device over the terminal server. Reverse telnet to get to the console port of the device. Use an expect script to break out of setup. Assign an IP address through conft, yada, 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 yada. Now the device is manageable. Now he can, we went through this, set up SSH access, clean up the initial configuration that was created by setup, deploy final device configuration, and verify that things work. And just for the fun of it, he added Slack integration, so the deployment team gets a message in the Slack channel that the devices are ready for deployment at the customer sites. And that's what you guys are missing in your demo.
Oh, we have chat-ups actually running in our...
Yeah, no, I believe you do. Anyway, his code is on GitHub, so if you want to check his code. Of course, as they have many customers, now they are going into creating different branches for different customers. Everything is now in GitHub, and so on and so on. Now for people who are doing really crazy stuff. This guy reduced the deployment time of MPLS services to 10 minutes. So he pre-generates all the configs, including the PE router configuration. Everything is automatically deployed. And they still need a technician on site. And the technician has to plug in the CPE device and power it up. And I think the technician has to configure the management IP address on the CPE device, because Cisco routers, they have no zero-touch provisioning. And his last addition, the last time we spoke, he built this cron job that would, based on Ansible inventory, scan whether new devices have been connected to the network. And whenever a new CPE device pops up, he automatically deploys the configuration to the CPE device and automates the final tests and sends confirmation emails to internal teams and to the customers so they can start monitoring the whole thing. So him being alone on this thingy, he said, I personally deployed 40 dual home sites over the last 2 weeks while having all the other work. Not that bad, right? This one is crazy. Government organization having to deal with site refresh at almost 2,000 sites. You know how much work this is. Okay. First, they would collect site information in an Excel spreadsheet. Excel, the universal tool for data collection. You see, they have to deal with local admins at these sites. You tell someone in the middle of nowhere to write you a YAML file, you will get what you ask for. You send that guy an Excel spreadsheet, ask him to fill that in, maybe have some formulas that turn cells red, which is called data validation. They convert the Excel spreadsheet to YAML data file. Based on that, they generate the device configurations for everything that will be deployed on site. So they're ready. Now, the real site deployment starts. First, they download the new config to the WAN router, and they enable the temporary DHCP scope on the LAN side so that the LAN devices will be properly configured. Next, the core switch is connected. It's a brand new device. It gets its IP address from the DHCP scope already configured on the router. Software is upgraded. New configuration is downloaded to this device that was created in this stage. And the final DHCP scope for all the other downstream devices is now configured on the core switch. Next, they power up all the access switches. And the access switches come up as dumb layer 2 switches with CDP running. And they use CDP to collect the actual physical topology for the site. They build an image of the physical topology. And then there's this GUI-based tool where the technician on the site looks at this topology and says, yeah, this is what I expected. Or, no, this is not what I expected. Let me fix this for you, and does some rewiring. So in the end, the technician on site says, well, yes, this is what we expected, so let's move forward. Final software upgrade, starting from the core switch down, they upgrade all the access switches, carefully, orchestrating this thing so that they don't cut themselves off. Rediscover the topology, verify that the topology after the software upgrade is the same as the topology before the software upgrade. Because software upgrades sometimes do fancy stuff, like breaking things. Final security setup, configuring static DHCP address leases, configuring DHCP scopes, configuring static ARP entries or DHCP ARP trust settings, configuring VLANs on edge ports. And then they configure the Aruba cluster master wireless access point and power up all the other access points, and all the other access points get their configuration from the master. They do some final checks. Like they document stuff like updating descriptions on the switch ports so that they actually match what's physically connected. And they go home. OK? Next one. This guy had to deploy a firewall cluster at like 100 sites. It was like, we're not doing this manually. So they create configuration snippets for directly attached Cisco devices. This being, I think he mentioned the firewall vendor, and I removed it for good reason. This firewall is not fully automatable. So they have to bootstrap the firewall manually. But then once the firewall is up and running, they could automatically deploy the final configuration, move the firewall into production, validate, and then, I love this one, automatically insert the new firewalls into the monitoring system. Once they say this site is ready, the site is automatically added to the monitoring system. There's no way that you could forget to do that. So now they have all the network parameters for a site in one YAML file. You have no idea how important this is, to have a single source of truth, to have a single source where your data is, to have a single place where you know that everything describing a site is. Network objects, they split into firewall policy, global objects, local objects. They're creating all configurations with one playbook, another playbook to add the site to the monitoring system, another playbook to do backups of configurations, and so on. And most importantly, everything is tracked in Git. So whoever, wherever, whenever changes anything, they know it. They know who and when made the change. Based on the verbosity of the commit message, they might not know why the change was made, but that's a different story. His lessons learned, migration time improved dramatically, no surprise there. They get the usual bonus like having the backup configs or automatically pushing configs. He said the most important part was that they started to have faith in their tool set. They did this often enough so that they know that the tool works. So if the process breaks, the first thought isn't, oh my, our tool. The first thought is something is broken, be it wiring or malfunctioning product or whatever it is, or wrong input data. This is a system integration deployment or outsourcing or something. So they had to work with the client's experts. And usually, the client's experts would have to review 100 almost identical configurations for 100 sites, just to prove that you're not doing something stupid to their networks. Because everything is templated, and the only way to make changes is through a template. The client experts reviewed one template. And then they can use that one template on 100 different sites. Mark Pryor had a presentation on my course about what he did for Betfair. He started with Arista's zero-touch provisioning, which is a really good zero-touch provisioning as opposed to what I had on one of the previous slides. So this one could check topology and upgrade firmware and deploy configurations and so on. And then he started using Ansible and Python to check that everything is working as expected. Check the LLDP neighbors, check the BGP neighbors, check that you have the routing tables where you expect it to be. And phase 2 is network infrastructure as code. Unfortunately, we can't get to that stage because we don't have switches as syringes. But we can get pretty close. So they do have version control in Git. They do use Jenkins for staging and testing. They do push configurations to devices through Jenkins with rollback capability. And everything is driven with Ansible and reported, of course, via Slack. And this is the one that triggered that trolling or serious comment, UBS. Everyone knows who UBS is? There's this tiny Swiss bank. They had this tiny problem. At a certain point in time, they had to do a total overhaul of 24 data centers. Every data center, the guy that did the presentation had pictures, was like 3 containers full of equipment. And he said, and those were the containers that you could use, you need the bike to get to the other end of the container. And according to their project schedule, they had a team of like 6, 7 people. And they had 2 years to get this done, which comes with all the holidays and everything down to 3 weeks per data center. So how do you deploy 250 odd pieces of devices in 3 weeks from 0 to ready for use? And you keep this going for 2 years without everyone going insane. The only way is to automate everything. And this is what they did. They spent a lot of time together with one of the vendors building the automation scripts. So as everyone, they have a decent data model where the site parameters are generated from a template. And then once they have the site parameters, the really important part is that their design is fixed. all the data centers look alike. All the data centers have a leaf and spine fabric. All the data centers have firewalls connected at the same place. All the data centers have load balancers connected in the same place, and servers connected the same way, and so on and so on. If you want to build 24 unique data centers, you will need 24 years to do it. Okay? So the trick is make everything cookie cutter. Because you make everything cookie cutter, the configurations are always the same. You just need to change some side parameters. But there are so many other things you have to do. You have to upgrade the software. You have to check the devices have the right amount of RAM and everything. If they were using some clustering solution where you have this crazy upgrade process that you can't do in one step and it has to be carefully orchestrated. They automated all that. And they've written like hundreds of tests. So they come on site, they run the first Ansible playbook. It does whatever it does, upgrade software, for example. And then 5 p.m., they run the tests, they go have a beer. Next morning, they come back, they look at the test reports, they see everything that has failed, they fix stuff, they run more Ansible playbooks. In the evening, they run the tests, they go have a beer. Next morning, they come back, you know the story. 3 weeks later, the data center is ready for use. Last step in their process, they run the last Ansible playbook that generates the ready-for-use documentation in wiki format. Because they have everything they need. They have the design, they have the site parameters, they have the actual device configurations, they have the wiring maps, they have everything. Bam, ops, please sign on the dotted line. Oh, where's the next data center? They were so successful with this that they used the same approach for campus refreshes, for remote site refreshes, and they have hundreds of remote sites. And now I think they are thinking about automating their WAN network. Okay, listening to all this, can you answer the question why all these guys decided to build their stuff instead of buying a miraculous vendor solution? Because they couldn't get the tool they needed. Either it was too expensive or it just didn't exist. And even if you buy a vendor tool, you will almost always find out that the vendor tool does 80% of what you need. And then you come to the classical stages of vendor acceptance. I hear you. Oh, I see your point. I understand what you're saying. But you know what? No one has asked for this before. Okay, I get you. I'll see what I can do. I'll get back to you. And a year later, they tell you it's on the roadmap. Now, let me tell you something. I've seen items disappear from the roadmap. And I've seen items being put on the roadmap and delivered in 2 years. So 3 years from now, you'll have the functionality you need, if you're really lucky. In the last years, the same vendors started deploying software-defined stages of vendor acceptance, which include, but we have an API. So you can do all this yourself. Why are you bothering us? Just buy our product and go away. We have an API. Which turns into you'll have to build it anyway. The only question is, how low do you want to start with your build process? Will you buy a fixed functionality system with an API like NSX or ACI or Cisco's APIC EM? These things do stuff, and they do have API that you can use to implement stuff that their stuff doesn't do. Which, for example, is what I've shown you previously with that ACI example. Oh, by the way, I have another ACI story. Just didn't ask that guy whether I can share that, so it's not on the slides. He wanted to treat his ACI in the network infrastructure as code way. And he couldn't do it because he couldn't get a text file that would be versionable. So he is working on a tool that will do exactly that. There's a difference between what this guy did and what network infrastructure as code guy wants to have. Namely, this guy pulled the parameters out and created a report, the read-only part. That's easy. Whereas for real network infrastructure as a code, we need an ACI or whatever network version of Docker Compose. Docker Compose takes your desired state, your actual state, and figures out the API calls to make to bring your actual state to the desired state. And that's really hard. So I don't know how far he got with his idea, but he's working on it. Or you can buy a platform like VMware vRealize Orchestrator or Cisco's NSO or Apstra AOS. All these things are platforms that do or not do something out of the box, but they are infinitely extensible with whatever you want to do. For example, I know people who are calling Ansible playbooks from VMware vRealize Orchestrator. The only problem with these platforms is I call them SAP of networking. They are immensely powerful. Learning curve is interesting. You will get consultants in that you'll never get rid of because they will be adapting the code to your needs for the rest of your life. Because your network is so unique. Okay? Or you can start with some low-level tools like Ansible is the lowest test level of them all. It's just a simple thing where you list what things should be executed, and it goes and executes them. It's like a bash script with half the functionality missing. SaltStack, Chef, and Puppet are a little bit better. StackStorm is a bit more event-driven. Anyway, so the takeaway from this presentation should be that you'll be developing software no matter what. You cannot afford to be just a network or infrastructure engineer any longer. I mean, everything I said today applies equally well to any other IT infrastructure. I just happen to be talking about networking because, you know, I'm this grumpy guy that used to pull wires. So no matter where you are in the IT stack, you cannot afford, or you will not be able to afford to be a sysadmin typing CLI or GUI commands for a long time. Of course, you will survive for the next 10 or 20 years. There are still COBOL programmers out there writing code for the IBM mainframes running OS 370. So there will always be jobs for those people, but I don't think you want to be there or you wouldn't be a troopers. So keep in mind that you will have to get some skills in this area. Whenever someone tells you that you have to become programmer, tell them they're stupid. Anyone out of high school can be a programmer. You invested 20 years into becoming an expert in your field, and now you will throw all that away and compete with kids out of high school? How stupid is that? But you have to start thinking in systems and processes and procedures and data structures and data models and decomposition and so on and so on. Don't trust vendor PowerPoints. Everything always works great in PowerPoint. And then someone told me just yesterday or the day before, oh, but we did this great demo with the customer, and it looks with the vendor, it looks so great. I was like, if you can't get your demo right, I wouldn't buy from you anyway. So don't trust the demos. And this is from Mythical Man Month. The book is like, what, 25, 30, 42 years old, 43. This is from the guy that was the project manager for the OS 370 operating system. And he said, well, the real tiger is never a match for the paper one. Or the tool I can build is never a match for the vendor PowerPoint, unless actual use is wanted. With this in mind, go out there, build something, and make your network a better place.